Alright, we're on week 9, set 2, SWYK number 1. Alright, got to have a conversation about the square root of -1. Now, that's not a real normal number, the square root of -1. I mean, I could tell you the square root of +1, because remember, a square root is a number times itself, which equals a different value. But what number do you multiply times -1 to get itself, to get -1? Actually, it's not in the group of numbers that we normally call the real numbers, right? This is the group of numbers you're very used to dealing with, all the ones that you have dealt with your whole life. It's in a different group of numbers, and it has an unfortunate name, I know, and it's called the imaginary numbers. Well, if they're imaginary, Mr. Daly, why do we have to deal with them? Well, it's just a different group of numbers that have some applications, especially inside of the electrical engineering realm. But I know, it's a different group of numbers. We will deal with simplifying them. We will, but not a lot of application type things will be dealt with them, at least at this level of mathematics. Okay, now, so we actually use the lowercase letter I to represent the square root of -1. We could talk about, well, what happens when you square that, So if you would square both sides, take I squared, what do you end up getting? If you square the other side, guess what you get? Now that is a real number. So that's bizarre. You take two imaginary numbers and you multiply them together and you get a real number? Whoa. See, you're very used to dealing with the real numbers, and the real numbers are called closed. Now, the reason they're called closed is if you take two real numbers and you add them or subtract them or multiply them or divide them, you end up with a real number. You have never seen a group of numbers where you can do an operation to two of them and end up with something that jumps outside of that group. So this is a weird, a whole new world kind of thing. Yes, Aladdin intentional pun there. We want to start out by learning how to simplify these things. And I want to bring up a property to you that you should understand. A product of two radicals can be multiplied together. They can also be separated. So, notice what I've done right here. Whoops, better lock that in place. I took the square root of -7 and I broke it up into the product of two parts, the square root of -1 and the square root of 7. Well, we know that the square root of -1 is I, and we know that the square root of 7 is an irrational number which does not simplify because 7 is not a perfect square, nor does it have any perfect squares trapped inside of it. So, that's as good as it gets. I square root 7. Sometimes we just say I radical 7. Okay? But that's the answer to that question. Moving on to the next one, if I can actually hit the right button. Okay? Well, what happens if you split it up and the other part's a perfect square? Well, typically we put the perfect square part in front and then put the I after it, so we say 9I. Now, I did notice up here on the last question, and let me clear this out, that it said, type your answer in the form A plus BI. Well, maybe we should have a conversation about that. A plus BI. So A is the real portion. And of course this is the imaginary. Now, when you put a real plus an imaginary together, you get what's called a complex number. Okay, complex number just means that's actually the biggest group of numbers out there. The reals are inside of the complex numbers. So the imaginaries are also inside the complex numbers. So if you add a real and an imaginary together, you get a complex. Now, if Math Excel is giving you trouble, one thing you could do is you could write this. Now, I think that's a dumb way to write it. I don't think it's a necessary way to write it, but it is the complex version of I radical 7. Likewise, if Math Excel decides to get, if Math Excel decides to give you some trouble on this one, you could write 0 plus 9i. Now, I don't think you need to. But if you should be getting a kickback from Math Excel, that's one way you could write it. Seems like a waste of time to me. All right, on question 3. What happens if you split it up? You take out your -1. When we're simplifying radicals, as we talked about before, we look for perfect squares, which go into, in this case, into 98. 49 goes in twice. So I know the square root, and you know what? I could actually put these two things together, just like we did on the last question. The square root of -49, well, that's 7i. Now the 2, I can't do anything with that, so I put it out here. And that's your final answer on that, 7i radical 2. Try to hurry up here because this video might actually be plot the complex number. All right, now how do I plot complex numbers? Remember, I just need to explain something here. The complex numbers. Now, this axis right here, called the real axis. This is kind of like the number line that you're used to dealing with when you were growing up. You know, they would say plot 2, and you know everybody would put their dot on 2, and plot 5, and everybody put a dot on 5. You know, and then of course you got into the whole x is greater than 3, x is less than or equal to 5, those kind of things. Well, the reality is we never taught you that there was an imaginary axis that was running right through 0. And so there were numbers above and below that real number line. And I know, we've been lying to you this whole time, hiding the truth from you because, you know, we thought your brains would explode. But you gotta introduce this stuff a little bit at a time, otherwise, you know, people can't handle it. Now, 2 plus 3i. That coordinate, that complex number, is 2 over and 3 up. There it is right there, 2 plus 3i. Likewise, 2 minus 3i is down here. Now, keep in mind, that's what we call conjugates. Now, those are not opposites, they're conjugates. Okay? Now, when you ask me to take the absolute value, remember that's the distance away from 0, -8i. Where is -8i on the graph? Let me hurry up and go over to the picture. -8i is right here at the bottom. I put it in with a red dot. How far is it away from 0? Well, that's pretty easy. It's 8 units away from 0. So there's not a whole lot of calculating. So that one's an easy question, really. You know, it's just 8. Now, what if it was something like this? What if it was 2 plus 3i? Well, 2 plus 3i, you know where that's at according to this other picture, right? It's that dot right there. Well, it creates a right triangle, you know. 2 to the right, 3 up. So when you ask me for its absolute value, I have to use the good old Pythagorean Theorem. Now, what the heck did I write that for? Let me see if I can erase that. Come on. Faster. This should not be there. In fact, it should be a square. Yeah. I know. Oh, I can't believe I did that. Because it should be the Pythagorean Theorem, right? A squared plus b squared equals c squared. It really is that simple, right? So we got 4 plus 9, and then we get square root of 13. So that is the absolute value, is the square root of 13. It's the distance away from the origin. So, some of those are easier than others. Like this one, all right? Let's see here. 5 plus 2i. Which one of those is 5 plus 2i? That's 5 to the right and 2 up. So, whoa, got to stop that from moving around. Yeah, it's this one right here. 5 to the right, 2 up. There you go. That's the point. 5 plus 2i. Now, what's the absolute value? Well, that's where we get into that whole idea of 5 to the right and 2 up. 5 squared plus 2 squared, square root 29. Yep, 25 plus 4 is 29. That's it. It's the square root of 29. Don't do weird things with that. You know, I've seen kids, I'll write -3 minus 7i like this and take the absolute value. You know what they tell me? 3 plus 7i. Okay, because they refuse to learn that it's just the quadratic formula. If you see the picture, it makes finding the distance so much easier because you're just a squared plus b squared. Just keep that in mind when you're working through those. Okay, question 6. What happens when you are adding these things together? Well, first I would recommend that you convert them get rid of the square roots and convert them into their I format. So that would be 3 plus I, and this would be -6 plus 4i. Remember that we are adding them together. I would also recommend that you then convert them into a vertical format like this. 3 plus I, -6 plus 4i. Now the reason I say that, and the reason I do it that way, is so that you, just like in elementary school, go down the columns and you add the like terms together. So, wait just a doggone second. 1i, yeah, that's 2 mistakes I found in my own notes. That's awful. What in the world? 1i plus 4i, shouldn't that be 5i? Yeah. 3 minus 6 does give me -3. Man, where was I? I don't know. Glad I caught it. Question 7. Now subtraction, right? Same thing, got to simplify the radicals. 3 plus 2i, 8 plus 6i. But when you distribute that -1, right? When we distribute that -1, that's -8 and -6i. Now the reason I distribute the -1 so that I can change it to addition. And then I can add down the columns and get -4i and -5. Okay? So, distribute the negative and change it to addition. And I think that's it for this particular one. Please say yes. What in the world are the answers to that? I don't know. That's weird. Okay. Have a great day. Sorry for the long video.